Good evening, students. I'll start with the class. In the previous class, we had done the multiplication theorem. What it says is P of A intersection B for independent events can be P of A. The P of B by A or P of A intersection B can be used as P of B A upon. So these are the two ways the formula can be used. So based on that, we were solving problems till problem number 4. That last part was the proof which I had done. After that, I stopped with the class. We'll continue with the problems on multiplication theorem. This question I'll just give these three. It must be there in the notes also. I'll just give a drawer. Question 5 on the notes. A drawer contains 3 red and 5 black socks. Those are mixed. If 2 socks are pulled at random without replacement, what is the probability that both socks are of same color? A drawer contains, so there's a drawer which has 3 red and 5 black socks. Now there are 2 socks which are pulled at random without any replacement. Okay, so one sock is first removed out and is not put back. Then another sock is also removed. Okay. Now both have to be of the same color. Same color means which are the 2 different colors. So we have to find probability that both socks are red. Okay, same color means either this also should be red, this also should be red, or both socks should be black. So what we have to find is probability of both socks are red or both socks are black. Or means always plus. Both socks means what? Both is A and B, means first one and the second one also. So sock 1 and sock 2 should be black. Or you can directly use these letters B1 and B2, black sock, or probability that both are red. This is ulta arrow, no? Both are red and here both are black. So the question is, what is the probability both are the same color? So they can either be red or both have to be black. So first one also red and second one red. Or means you can put plus. Or means in probability is always plus. And means multiplication. This intersection sign. So this is what is asked. Now these are dependent ones. Obviously, depending on which was the first sock, the second one probability will depend. Okay. So we know that straight away we'll use one of the formula. P of, what is that, R1. First, what is the probability of the first sock? And then probability R2 is dependent on the first one. Probability that the second sock is red is dependent on the first one. Same way here also. Probability, this is first one. First one is not dependent on anything. So it is straight away P of B1. Okay. Into the second one is definitely dependent on the first one. Probability of B2 is dependent on B1. What you can write and keep, this is what, based on first sock is red, what is the probability that second sock is also red? If first sock is red, what is probability of second sock to be red? Okay, this, given that first one is already red, what is the probability of the second? So it's calculated. Very simple. This is what is probability of, see, I'm starting to perform the experiment now. I'm given this box. Now I'm going to pick up one sock. So which sock should come out as per this red? What are the chances of red sock coming out for the first time when I'm picking the first sock? So there are 3 red socks out of how much? Total how many socks are there? Total 8 socks. So probability of PR1 is, of the first one being red is, so this is first sock red. How much it is? 3 out of 8. 3 red out of total 8 socks. Into, now already we are assuming that the first one is already red. Okay, already one red sock came out. So how many will be left? 2 red, then 5 black. So total will be how much? 2 out of 7. Because you are not replacing that sock back. And plus, what are the chances of the black? Black is 5 out of 8. And now the second thing, what you are assuming, given that already the first one was black. Given the first one is black, first sock, what is the chance that the second sock is also black? So out of this one, suppose black had come out. So first one is one black came out. So there'll be 4 black left out of 7. Now you have to calculate and write down. Keep this common. So 13 upon 28 will be the answer. Okay, this you write and keep. Because later when you're studying, you should know second sock is red. If first sock is red, what is the probability that the second sock is also red? So one sock will be out. So you have to minus one sock, so it will be 2 out of total 7. These next 2 questions are not there in the notes. I'll just give similar to this only there. I'll use it as question number 6. 2 cards are drawn from 52 cards. Find probability that both are aces if the 2 cards drawn are are drawn one after another. First one is without replacement. Second one is with replacement. There are 52 cards. Okay. Out of 52, two cards have to be drawn and both have to be aces. So first ace 1 and then ace 2. Both have to be aces. We have to find probability of both aces. Means what? Probability that ace 1 and ace 2. First card is also ace and second card is also ace. Before writing, you can write A1 means what? First card is A. A2 is second card is also A. So I'll use the multiplication theorem. Without replacement means the second one is dependent on the first one. First one is not dependent on anyone, but the second one, A2, is dependent on the first. This how to read. Given first card is ace, probability that second card is A. First, how many chances are there? How many aces are there normally? In out of 52 cards, there are 4 aces. One of diamond, one of spade, one of club, and one of heart. So there are 4 options. Out of 52 cards. Now when already you are removing one ace out, so inside how many will be left? Only 3 aces out of 51. This will be 3 aces out of 51 cards because one card is gone out. So second time when you go to pick up, you have only 51 cards left. And when you're saying the first one was ace, so that means in the box there will be only 3 aces left because one is gone out for the first time. Calculate and write your answer. It is 1 upon 169. This 13. 1 second. 1 upon 13 into, so that will be 1 upon 221. So without replacement means always conditional probability. With replacement means independent events. With replacement means what? You are taking a card, picking a card, you are looking at it and you are keeping it back. So will the second card be dependent on the first one? No. With replacement means I pick the first card, I look at it, I put it back. So again, when you go to remove at the second time, you'll have 52 only. It is not dependent on the first one. So with replacement, if they say, then it's always independent. The second part is with replacement. Proceed with. So second one is not dependent on the first one. Directly this into this. Because this will go. Is it dependent on the first card? No. Why? Because once you see, again you're keeping it back. You're not keeping it at the side. So first time when you go to pick up, how many options will have? 4 out of 52 cards. 4 aces out of 52 cards for the first time. You see a card, you remove. Now what is happening? Again you put back. The second time when you go to pick, again you have the same option left. Again you'll have 4 aces only and 52 because you're not keeping it at the side. So again 1 by 13 into 1 by 13, that is 160. This is with replacement. You have to always take independent events, straight away just multiply. 1 by 2. Write the seventh one. 3 cards drawn from 52, one after another. Find probability of drawing 3 spades. First one is without replacement, and second one is with replacement. Okay, now 52 cards are there, 3 cards are drawn one after another. So it should be spade 1, spade 2, spade 3, all 3. All the 3 cards should be spade. So we have to find which is same as probability of spade 1, second card also, and third card also spade. Now if you have 3, you know how to split this is as first one is not dependent on anyone. So it is just P of S1. Now second one obviously is dependent on the first one. P of S2, probability of the second card is dependent on the first. Because you're doing without replacement. You're keeping it aside. So second one is dependent on what was the first card. And then when you go to pick the third one, it is dependent on the third one is dependent on the first two. Second card is dependent on first. And here third card is dependent on First two. First two cards. I want the first card to be spade, second card to be spade, third card to be spade. First one is not dependent on anyone because the first time when you're starting, you have all the options there. So first when you start, you will have, how many spades are there? There are always 13 spades out of 52 cards. So first time when you pick up, you have 13 options out of 52. Now what you're assuming, one fellow is gone. So this had all 13 out of 52. Now the second fellow, what is happening? One is already gone. One spade is out. One spade is out means you'll have only 12 spades out of total 51 cards. Then two spades out. You're assuming first and the second was a spade. So only 11 spades will be left out of 50 cards. Then calculate right answer. So answer should be 11 upon 850 after calculating. Second point is with replacement. With replacement means they are independent events. First one is not dependent on the second one, or second is not dependent on the first. You are removing, you are looking, you are keeping it back. So it's like starting all over again for the second card also. It has nothing to do with the first. That's why they are called independent. If they are independent, they will be all separate directly. Probability is there. The probability of S1. First time when you go, you have 13 out of 52. Second time also you will have 13 only because you are keeping that card back. So when you go, second person comes to pick the second card, same options will be there. Third person coming to pick the third card, same options. So 1 by 64 will be the answer. Next one. Three cards from 52 are drawn. What is probability that first two are queen and third one is a ace? First, with replacement, we'll do without replacement. First, without replacement, and second is with replacement. So you know that we'll assume Q1 is first queen, first card queen. Q2 is second card queen, and A will be ace. Third card is ace. Now we have to find probability of Q1, Q2, and third one is this. Now first time when you go to pick up, the first time I'm doing without replacement. So without replacement means whatever I remove, I have to keep it at the side. So first one is Q1. So I'm keeping this card side after getting a queen. The second card is dependent on the first. The third card is dependent on the first two. Out of 52, there are 4 queens, 4 aces. So first time I want queen. Probability of queen is 4 out of 52. Okay, 4 queens and there are 52 cards. Now for the second time what is happening, I am assuming that first one Q1 is gone out. First one is a Q1 which is gone out. So how many queens will be left? 3 queens. Out of total, 1 card is gone out, so 51 cards. So 3 queens. For the second one to be a queen, there are only 3 options. So 1 queen is out, we are assuming. Now the third one should be, now we have to look for the aces. So there are, because this is for ace, we have to calculate probability. There are 4 aces, but what we are assuming, 2 queens are already out, Q1 and Q2. So how many cards will be left? Only 50 cards. But aces, 4 of them are there because they are not gone out, only queens are gone. So there are 4 aces out of 50 cards. Only queens are gone out. But aces, when you go to pick the third card, how many options you have? 4 aces will be there in the box. But cards, how many will be there? 50, because 2 queens are out. Those 2 cards you cannot take. And calculate and write down. So 2 upon 13, 17 into 20. And then with replacement, independent events, we directly have to multiply. Q1 is how much? First time when you go, you have 4 out of 52. Again also, because the card is put back, still you will have 4 out of 52. For ace will be, there will be 4 aces again out of 52. 1 by 13. Okay, so this was about problems based on multiplication theorem. Next is theorem of total probability. Before starting with theorem of total probability, I just teach you what is something called as partition of space. Sample space means it is all the possibilities whenever you do any experiment. Like when you say I'm throwing a die, the sample space means all the possibilities without any conditions. That on a die it could be number 1, 2, 3, 4, 5, or 6. That becomes a sample space. So it's like a universal set. And then whether it is even number, odd number, bigger than 3, less than 3, all those are events. Those are smaller parts. So if you want to draw it in form of a diagram, then this whole box is like a sample space. The sample space I'll consider as a rectangular box, and I'll divide this into small events. The sample space, maybe this is for even number, this might be for odd number, this may be prime numbers, this the number is greater than 3, like that. Okay, any event which you want to consider, so just divide randomly however you want. You just have to divide a space. So this may be E1, E2, E3, so on, all this, and last one will be En. We don't know how many we are dividing it into. Randomly we are dividing into n number of events. So I'm partitioning, okay, making small partitions. A set of events E1, E2, E3 up till En. Okay, these are the events. S is the sample space. Now what is this relation? You have to make sure this event is not dependent on the other one. First one says events are disjoint. Disjoint means not dependent on each other. E1 is not dependent on E2. It's nothing they have in common. Okay, they are not sharing any this. So this line, this is separating E1 and E2. So their disjoint means intersection between them is always equals to 0. There is nothing common between E1 and E2. So in general, I'll use a different letter I and J because it applies for all the numbers. Where I comma J is what? 1, 2, 3 up till N. Because this works for 3 and 4 also. It might work for 3 and 9 also, 10 and 15 also. So randomly every event is independent from the other one. This is the first condition. Second one, if you add all these events, you should be able to get sample space. Adding means what? Taking union, combining all the elements. The second one, they are called as exhaustive. Exhaustive means if you add all the events up till En, that will should be equal to your sample space. The third one, non-zero probability. Means none of this event should have a probability 0. All should have some probability or the other. Imagine there is one event which I am creating. This suppose sample space is for a die, and now this event which I have created, I am saying number greater than 6. Obviously, number greater than 6 is not possible, so probability will be 0. So such events I cannot write. So you have to make sure these events do not have 0 probability. It should have non-zero probability. Some probability should be there. So probability of any event should be greater than 0. I could be for all the I goes from 1 till n, all the values. So these are the 3 conditions for any partition of a sample space. First thing, that they should be independent from each other, nothing should be common between them. Second, when you add all the events, it should give you the sample space. And the third one, they should be positive. Probability should be positive, cannot be zero. Now, based on these three conditions, this proof is asked for exam. Theorem of total probability. State and prove the theorem of total probability. Then you have to do the statement. This is the statement. Let, with reference to that partition only. Now you should be able to understand. Let E1 is all the events, E2, E3, E4 up to the end be the partitions of sample space S. Suppose, now write all the three conditions. Suppose each of the events E1, E2, E3 up till En are disjoint, exhaustive, and have non-zero probabilities. Occur. Let A be any event associated with S. Then, so what they are basically saying, now this is the partition. Now we are just assuming another big event, one main event, that is A. Okay. Suppose there is one big event A inside this. Now this A, probability of this one you have to find, suppose, which is associated with the sample space. Where A is like a main event. And it is given as P of A is multiplication theorem you have to apply. If I'm using A, E1, this E1 will go to the denominator here. Then if I'm using E2, just write this in the denominator. Same way, P of E3 will be P of A upon E3. Same way, P of En will be same of A upon En. So this is the statement. So what is basically changing? Only these numbers are changing. Rest everything is remaining same. Only this subscript of E is changing. So I can generalize this formula. This is summation sign. I'm adding all these terms 1, 2, 3. Only what is changing this term. So I'll generalize this. So it is basically P of E into P of A upon E1. Everywhere A upon E. Just see, this is the same thing everywhere. Only what is changes is the number. So I just use another letter. I put J in general. So J values are from where? It starts from 1 and goes till N. So this is how we write for summation sign. In general, we are adding the same term. So every time we just have to put 1, then again 2, 3, 4 like that. Till N you have to put. So J value is from 1 to N. So either you remember this or solving problems, you have to use this one. based on how many events are. So this is a statement. We'll prove it. Write the same thing again. Let, okay, proof is already I have given the statement. Now given that E1, E2, E3, even events, we know sample space is nothing but addition of all. If you add all of them, if you unite, union means what? Basically, you're combining all of them. If you're combining all of them means it should give you the sample space. Okay, so this is first one, equation 1. Also, we know that A is same as A intersection S. If you take common something with the sample space, just look at this. If sample space is 1, 2, 3, 4, 5, 6, and A is suppose 2, 4, and 6. Now I want to find intersection between them. I want to find what is A intersection S. So which are the common elements? 2, 4, and 6. We'll get the same thing. So any event you take intersection with the main sample space, you'll get back the same thing again. Any sample space you have and any event which is a subset of this, you take an intersection, you will get back A only. Okay, so what we'll do now, we know this statement, only this part you have to remember, this step. Then you have to substitute this entire thing over here. A will become what? A intersection. Put this E1 union E2. Put the value of S there. Now distribute this A to everyone. In A intersection U2, E2, then A intersection E3. This part apply to everyone. Same way E4 also up till En. Now we'll take probability on both sides. Take probability on both the sides. This will be P of A. This will be P of Now P is only outside. Now you know that one thing is they are exhaustive. Second, you know that they are disjoint. Three conditions I told you. Disjoint means you know that PI intersection is J is 0. So they have nothing to do with the other ones. So union I can directly put it as plus sign. Union means or means always plus. Intersection means and, which is always multiplication. So instead of U, I put plus. And now open up the bracket, apply P to everyone. Or before that I do. Now you are applying this P to everyone. Now open up the bracket, apply P to all the term. Now the last step, P of same. What is there in the statement? P of A intersection B can be written as the second theorem of multiplication. If I'm using E1, then P of A is what? If I'm using P of E1, then this P of A upon E1, it will, this E1 goes down. Whatever I'm using here, I have to write here down. Then if I'm using P2, P of E2 here, then this is apply multiplication theorem. And that's a proof. Which is nothing but summation of 1 to n. This is theorem of total probability. If it comes for 3 marks. Only statement if they ask, that comes only for 1 mark. Without the proof, only the statement if they ask, you have to, for 1 mark, then only write the statement. For state and prove, then it is for 3 marks. Now we solve problems based on theorem of total probability. Share the slide. This is, I think, Bayes theorem. Wait 1 second. A bag B1 contains 3 copper coins and 2 silver coins. There are 2 bags, okay? And bag 2 contains 4 copper and 5 silver coins. A coin is picked at random from one of the 2 boxes. So you don't know from which box it is. You're picking. What is the probability that it is a silver coin? So first thing is you have to frame this diagram. Diagram is for your reference. Just always read out the question. The question I'm just reading and simultaneously doing. What you're saying is there are 2 bags, B1 and B2. Bag 1 contains 3 copper coins, 2 silver coins. Bag 2 contains 4 copper coins and 5 silver coins. A coin is picked randomly from one of the 2 boxes. We don't know which box we are selecting. Okay, let's write this data first. So we have to use theorem of total probability. Later you will understand when to use probability, and then 2 theorems are there, total probability and Bayes theorem. 100% there's one question which appears either on total probability or Bayes theorem for 4 marks. Out of 7 you can keep straight away 4 marks separate. Mostly Bayes theorem comes. But to understand Bayes theorem you have to know this also. Okay, so we have to name now what all things we had seen under theorem of total probability. There's always a main event A. And there will be always small events, E1, E2, E3, so on. So now based on the question, these events will change. Now there are 2 boxes. And there are 2 boxes, there will be only 2 events. If there were 3 boxes, there would be 3 events. Now main event is what is the final question asked, that becomes always your main event. So what is the probability that is the silver coin? So A, we will take it as silver coin. Means probability of A. A silver coin is picked. So one coin has been picked out of the 2 bags. Now events E1 is what? Suppose now you are going there. I give you a task. Go and pick one coin and come back. So now you have 2 choices. Now I don't know whether you have to pick bag 1 or bag 2. Now maybe you are going and maybe selecting this one. So let E1 be what? For box 1. So what are the chances? This is what probability that box 1 is selected. What are the chances? You go there, how many options you have? You have 2 boxes, 2 options. So total how many boxes? Total 2 boxes. So you are picking one out of the 2. Same way, another option, suppose E2, another student goes, they have box 2. Okay, so there is an equal chance for this also. There's half probability. You could have 50% chances that I'm thinking now which box you must have chosen. So out of 2, 50% chances are here, 50% chances are here. The probability is half. Either box 1 you will select or box 2 you will select. That is for sure. You will not come back because compulsorily you have to select one box and pick a coin and come. So if box 2 is selected, even box 2's probability is how much? Equal chances. The probability of E2 is what? Box probability that box 2 is selected. For what? To pick up the coin. The probability of E2 will be half again. Now try to think of the theorem of total probability. Always from here onwards, whichever problems are there, okay, it will always have this probability of A we have to find. What probability of A? Write somewhere on the list and keep always the problem. This order you have to follow. You have to find what is P of. You have to write what is P of A. Okay, and that will always be maybe given or you have to put a question mark. So write P of A. Then the second one you have to write P of E1. And you have to write P of E2. This is a fixed order, never change this. Then third one will be always P of A upon E after this. Then it will be P of A upon E2. If there were 3 events, then P of E3 and P of A upon E3. So these are the fixed things which you have to solve, okay, for every single problem. I am not going to change these letters because it should fit in your head. Teachers use different letters for different problems, but it is always confusing. So we'll stick to only these letters, E1, E2 for every single problem from here on, maybe 20 problems or whatever it may be. I'll stick to this notations only. So what have we done? P of this we have to find probability that it is silver coin is picked. Now next I found out what is P of E1, that is box 1 is selected, P of E2 is also selected. This is done. This I did, this I did. Now next I have to go for here. Now how do I read this? I know that I have to find this. Now just try to read. You have to always start from this. Given that, what is E1? E1 just refer here. What is this? P of E1 is what? Given that the box 1 is selected. Given that box 1 is selected. Always read this first. Given that box 1 is selected, what is A? What is the probability that it is a silver coin? So what they are trying to say is, if box 1 was selected, what is the probability that you went and picked up silver coin? You suppose went and selected box 1. I want to pick a coin from this. Now what are the chances that it is a silver coin which you pick? So total how many are here? Total coins, 5 coins. Your total how many coins are there? 9 coins. So here 2 out of 5. So P of A upon E1 is chances of it to turn out to be silver is 2 out of 5. If they had asked for copper coin, this would have been copper and it would have been 3 out of 5. If in the question, if it was asked copper, then it would be 3 out of 5. But now they have asked silver, so the chances are 2 coins are there out of 5. Now this also we did. Now move to the this step. Next is P of, if you by heart this order, no, all the problems will become simple because you just have to read them. You have to read always this, given that way you have to read. Given that, what is E2 means? E2 I have taken for box 2. Probability that picked coin is a silver coin. So what will be the chances? If it is from box 2, if you had selected, if box 2 was selected, if it's a silver, it was 5 out of 9. You're done with the data. Now just apply theorem of total probability formula. Theorem of total probability says always this multiplied by this multiplied by this. P of A is nothing but, if you want to find this, P of E1 into P of A upon E1. Middle sign is plus P of E2 into P of A upon E2. And just substitute the values now. So this was half, this was 2 out of 5, this was again half, this is 5 out of 9. You calculate the value and write down. So 43 upon 90 should be done. Can cancel this. No, solve the second problem similar to this. The second question is, 3 children, Rita, Geeta and Sita. 3 children, Rita, Geeta and Rita often help their parents in the kitchen. Okay. Now what happens when they go to the kitchen? They break a dish. Whenever they're cleaning, they always tend to break a dish. So what are the chances of them breaking the dish? First one, if they go, there are chances that one third chance. Second probability is 2 by 3. The third person is 1/2. That is Rita. Now, if one of them is selected at random, now you don't know which one the parent is choosing out of these 3. And then that whoever that child is sent to the kitchen. Now, what is the probability that the dish is broken? So you don't know which one is selected. Then, if one of them is selected, what is the chance that the dish is broken? So there are 3 children. So instead of 3 boxes now, so it will be 3 children. Data is the correct order. This is the first one, Sita, Geeta. Total are 3 children. That's why there will be 3 events. If there were 3 boxes, there would be 3 events. Same way there are 3 children, so there are 3 events. If there were 2 children, it would be just 2 events. Now obviously how you have to start the order now. This will be a main event. And you have to find probability of E1, then probability of E2, probability of E3, then P of A upon E1, P of A upon E2, P of A upon E3. So this is the list which you have to find. So let us take the main event, P of A that the dish is broken. That's the main question. So that becomes a main event. Now E1 is what? You don't know which of the girl is selected. So let us take E1 that Sita is selected. The parent goes and selects Sita. What is the probability? Probability that Sita is selected. P of E1 will be how much? How many options the parent had? 3. So Sita is one of them. So it will be 1 by 3. Same way, P of E2. So E2 is for Geeta. P of E2 is what? Probability that Geeta is selected. Again, how many chances? P of E2, 1 out of 3. And E3 also same. Rita. Probability that Rita is selected. So P of E3 will be 1 by 3. Now this is done. Next is to write this. Given that, read from here first. Given that E1 means what? Just look here. Given that Sita is selected, probability that A means what? Dish is broken. How much has been given? Look into the question. P of when Sita is selected, they have given that the probability that the dish is broken is 1 by 3. When Sita is selected, Sita's chances of breaking the dish is 1 by 3. Then same way, P of A upon E2, given that Geeta is selected, probability that dish is broken in the question it is given as 2 by 3. P of A upon E3, given that now Rita is selected, probability that dish is broken is 1 by 2. Now found out all the 3. Now you know that. Just first E1 into this, A we know, E1, E2, E3. This was P of A upon E1, P of A upon E2, P of A upon E3. So this into this, this into this, this into this. This was 1 by 3 into 1 by 3 and calculate the answer. This is 1 by 9. This is 2 by 9. This is 3 by 9. One by 2. Only framing you should know, and data calculation part anyway is simple. The last problem. Third one. A box contains, so there are two boxes now. It is same like the first question. Instead of coins, now they are marbles. Okay, one first box contains 2 white and 3 black marbles. The second box contains 4 white and 2 black marbles. Now one marble is drawn from one of the box. So now you don't know which box was selected. Find the probability that it is a white marble. So write the data always. If you get the logic how these problems work, they are very simple. Straight away you can get 4 marks. So there are some typical problems, not like same thing, only numbers and the conditions will change. That's it. But that main formula, that finding A, E1, E2, that is same. So there's one box, 2 white, 3 black marbles it has, and box 2 has 4 white and 2 black marbles. So this is box 1, this is box 2. So total how many? 2 boxes. Here total how many marbles are there? Total 5. Here total 6 marbles. So 2 boxes means E1 and E2 will be. So what all we have to find now? A, probability of A we'll have to find. What is probability of E1? Probability of E2, then probability of A upon E1. If there were 3 boxes, then E3 would come up. Now this is the sequence which we have to find. Now P of A is a main event. What is been asked is probability that a marble is white. This is the main question. This we have to calculate. Now E1 is what for box 1? The probability of E1 is box probability that box 1 is selected. So how many boxes are there? 2 boxes. When you go, you have a chance of selecting 1 box out of 2. Okay, same way. Now E2, that is for box 2. So P of E2 will be what? Probability that box 2 is selected. P of E2 is also half. This is done. Done. Now P of A upon E1. Now read from here. Given that E1 means what? Box 1 is selected. Probability that it's a white marble. So for box 1, 2 out of 5. Because there are 2 white marble out of 5. If black was asked, it would be 3 out of 5. Then find P of A upon E2. Given that box 2 is selected, probability that A remains the same. Marble is white. From box 2, what are the chances of the marble being white? 4 out of 6. That is 2 out of 3. 4 marbles, white marbles out of total 6 marbles. So got this? So multiply. So 8 upon 15 will be the answer. Let's stop here. Tomorrow's class is completely based on today's. Those who have not attended, I have nothing to do with them. I'll do my duty of completing the portion. Tomorrow, those who attend and they don't understand, that is their problem.